guys and welcome. In these presentations, we'll take you through a comprehensive journey into our scientific explorations. I'm Zahra, joined by Nafisa and Aish, and together, we'll guide you through our Chemistry 256 project. We'll begin with an introduction, followed by our methodology, a deep dive into the titration process, and a look at our results. We'll also discuss the effect observed, storage stability, and wrap up with a summary of our findings. Assalamualaikum and hi everyone! In this video, we're going to talk about how to measure vitamin C content in different herbal juices using a simple lab method, which is direct titration with iodine. We all know that vitamin C is important. It helps with things like immune function, wound healing, and it also acts as antioxidant. It's commonly found in fruit like guava, lemon, and passion fruit. But have you ever wondered how we actually measure vitamin C in something like juice? In this study, they focused on that exact questions, and they tested several herbal juices using a quick and affordable method. Firstly, I will start with the methodology and application. So, instead of using advanced equipment like HPLC or UV spectrophotometers, the researcher went with a direct titration using iodine. It's a classic chemistry method, and here is how it works. In simple terms, iodine reacts with vitamin C. So, if we add a known concentration of iodine to the juice samples and measure how much it reacts, we can calculate how much the vitamin C is in that juice.
Assalamualaikum. My name is Nafisa and I'm going to continue for the next. For this task, they use 5 juices from 5 fruits: guava, Emblic myrobalan, lemon, sweet pepper, and passion fruit. They also tested both fresh and freeze-dried sample to see how storage or processing affects the vitamin C level.
It really helps me to see what is going on. Super close now. I should be really careful on my drops. One drop. Ooh, almost there. One more drop. One more drop.
The juice sample were treated with 0.1 iodine solution using starch as an indicator. The reaction changes color when all the vitamin C is used up, and that's how they knew how to stop. They also validated the method by checking things like precision, accuracy, and linearity. The results were really solid. The method showed excellent linearity and good reproducibility with minimal error. Next, the results showed that vitamin C level vary quite a bit depending on the fruit. The highest was in Emblic myrobalan, about 2 to 6 mg per 100 grams. Guava was next at 80 mg, then sweet pepper, passion fruit, and finally lemon with the lowest. When they freeze-dried the guava and Emblic myrobalan juices, there was some loss of vitamin C, around 41% for guava and 20% for Emblic. But what's interesting is that freeze-drying helped preserve the vitamin C over time. Fresh juice stored in the fridge lost a lot of vitamin C after just a few weeks, while the freeze-dried one remained more stable. After 8 weeks, even the freeze-dried sample had barely any vitamin C left.
Now, we will look at the storage stability of vitamin C in herbal juice comparing fresh juice and freeze-dried juice. First, we found that fresh juice degrades faster. This means the vitamin content in fresh juice drops more rapidly over time. On the other hand, freeze-dried juice was able to retain more vitamin C, especially within the first weeks of storage. This shows that freeze-drying is more effective in preserving vitamin C. However, even in the freeze-dried samples, after 8 weeks, only traces of vitamin C remains, which suggests that vitamin C degrades over time regardless of the method, but freeze-drying helps slow it down. This highlights the importance of storage method in maintaining the nutritional value of herbal juices, especially when they are rich in vitamin C. So, to wrap it up, this study showed that the direct titration with iodine is a simple, fast, and reliable method to measure vitamin C in herbal juices. It doesn't require any fancy instruments, and you can analyze a sample in under 5 minutes. Guava and Emblic myrobalan had the highest vitamin C, and even though freeze-drying caused it some loss, it helped maintain the vitamin content longer during storage. This method could be useful for quick testing in food science, supplements, or even student labs.